السلام عليكم ورحمة الله وبركاته. أهلا بكم أبنائي وبناتي طلاب الصف الثاني الثانوي. نرحب بكم مع منصة البث المباشر جمهورية مصر العربية وزارة التربية والتعليم. معكم مستر حسام حسن. Now we start in our session in chemistry for second year in secondary schools. We now start for the hybridization session. What the meaning of hybridization? Before I illustrate the hybridization, before I illustrated the types of bonds. Now I reviewed the types of bonds. Now we have many types of bonds in chemical bonds, ionic bonds, and covalent bonds. In our trips, we reach the hybridization, and we want to know the concepts of hybridization. What the meaning of hybridization and why hybridization occur in our covalent compounds. Hybridizations occurs between orbitals of the same atom. This is the first condition, in the same atoms. Okay, not between two atoms, no, the same atoms. Why? That are closed in energy, 2s and 2b, 3s and 3b, 4s and 4b, and so on. The hybridization between the pure orbitals in the same atom, okay, are closed in energy, such as 2s and 2b orbital. The number of hybrids orbitals produced in this atom is equals to the number of pure orbitals. That's participates in the hybridization. The shape of the hybrid orbitals differs from pure orbitals that formed them, making them more prominent. What the meaning of prominence? These interactions between the hybrid orbital and the other orbital for the other atoms, we have many interactions or overlapping. This overlapping needs prominence. This is easy for this overlapping and better suited of overlapping. This is overlapping making covalent bonds. Capabilities compares to regular orbital. This is condition of hybridization. What is the condition of hybridization? Hybridizations makes in the orbitals is closed energy levels. Atomic orbitals involves hybridization must have orbital close to each other in energy. For example, 2s and 2b orbitals. I have carbon when electronic configuration of carbon atoms in ground state, we have 2s2, 2b2. Now carbon transfer into the excited carbon atom, the electron, and 2s will transfer to 2b. Now it converted in 2s1 and 2bx1, 2by1, 2bz1. We have three pure orbitals have one single electron in each. When this is the excitation process makes a carbon atom, we must the overlapping between four orbitals. These four orbitals will distribute the energy for this orbital. Why? Because this is energy of 2b is more than 2s, but they are closed in energy. But we need four orbital are equal in energy. So in this process, this is make hybridization SBBB. So it is SB3 hybridization. Now we have SB3 hybridization in this compounds. Number two, number of orbitals. The number of hybrid orbitals formed is equals to the number of pure atomic orbitals. So if S mixed with 3p is formed 4 orbital sp3, the pure orbitals S plus 3p Now we have three pure orbitals. This is three pure orbitals equal to hybrid sp3, 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 sp3. We have four sp3 called hybrid orbital. Now, in this conditions, number three, it must be in the same atom. Hybridization occurs within the same atom, involving its own orbitals, not between two atoms. This is very important condition. The hybridizations occur in the same atom, between two closed or more too close. We have SCP3D, but we didn't teach these types of hybridization. I have SCP3, and many times I will explain that. Number four, bonds formation. Hybridizations typically occur in these atoms to facilitate the formation of covalent bonds, resulting in more stable and stronger bonds. This overlapping between sp3 and S, or sp3 and another pure atoms for the central atom's carbon, this overlapping between two atoms to form covalent bonds. It is more strongly than the other because I told before, it prominence for overlapping. Okay, now we have this condition for geometrical arrangements. The resulting of the hybrid orbitals have specific geometric arrangements that's mixing the distance between them, reducing electron repulsions and leading to stable molecular structures. Electron density in this, we have in this is a pure orbital. This is a pure orbital. This is a pure orbital. This is pure orbitals will mix to form the hybrids, the hybrid orbital. This is hybridizations make geometrical shapes for making the distance between them. The electrons will reduce to reduce the repulsions, the repulsion forces between these electrons to make what? To make stable molecular structures. Now we have from this repulsion forces make angle between these atoms. Between these bonds to form triangle, tetrahedral, and so on. We have this bond angle of CH4 equal to 109.5 in methane are explained by the fact that each hybrid orbital contains a negatively charged electron. These orbitals repels each other and arrange themselves in spaces as far sparse as possible to minimize repulsion force. We have this angle 109.5. This is structural for this angle. More stable, this arrangement leads to tetrahedral geometric shapes of methane CH4 to ensure that ensuring maximum stability and minimal electron repulsions. Now we have many types like NH3. I will illustrate it. NH3. It is ammonia gas. This is hybridization in the nitrogen atom of the ammonia molecule, NH3. NH3, when you make electronic configuration in your paper now, you have an atomic number 7. Helium 2, 2s2, 2b3. We have 2s2. This is lone pair of electrons. 2b3, 2bx1, 2bx, 2by1, 2by, 2bz1. I have three pure p orbitals. Each orbital have one single electron. Now form NH3. N will make three bonds between central atom nitrogen and three hydrogen atoms. Hydrogen 1s1 single electrons. But nitrogen will make hybridization sp3. Why? Because we have 4 bonds. Now I have no 4 bonds, but I have 3 bonds and one lone pair. Okay, I will illustrate this as this hybridization nitrogen atoms of the ammonia molecules and H3. In this ammonia molecule and H3, there are three identical bonds. Three identical bonds. This occur through hybridization process between 2s orbital, 2s2 will make this hybridization, which contains pair of electrons and s and three 2p orbitals, now making sp3. Each of these orbitals form a bond with the hydrogen atoms through a shared pairs of bonding electrons, while one pair of electrons remains as lone pair on the nitrogen atom. We have this shape of ammonia gas. We have sp3s, sp3s, sp3s. This is a shape. What is this? This is a sp3s. We have lone pair of electrons doesn't share with this bonds in s orbitals. Now this is binding between them form three orbitals, three hybrid orbitals, three orbitals forming the three bonds in this structure. Each of this orbital form a bonds with hydrogen atom through this shared pair of bonding electrons, while one pair of electron remains lone pair of 1s and 2s2. I'm sorry, 2s2 nitrogen atom. This means that there are four regions for electron density around the nitrogen atom. Therefore, after the hybridization that occur in nitrogen atom of the ammonia molecule, the hybridization is sp3 hybrids. Now, we transfer for this another type of hybridization. I told before we have many types of hybridization, but we'll study the type sp3 I studied before, sp2 I will illustrate now, and sp maybe in this session I illustrated, maybe next time I will explain that. Now the hybridization in ethylene molecule. Now use your paper and your pen, write C2H4. C2H4. C2H4, it is the molecular formula of ethylene or ethylene. Ethylene C2H4, if you make building shapes, C double bond C, and each C related with two hydrogen, CH2 double CH2. Now carbon make double bonds between carbon and two single bonds between two hydrogen. Okay, why sp2, not sp3? The reason for sp2 hybridization is that each carbon atom forms three single sigma bonds. I told before what the meaning of sigma bonds. Sigma bonds forming between two atoms by overlapping head to head. I mean linear or collinear overlapping. I have many types of overlapping. I have collinear overlapping, head to head, or side by sides. By sides makes parallel. I will explain this another types of bonds. I have bi bonds and single bond or sigma bonds. I told before, sigma bonds is collinear overlapping, head to head. It is very strong bonds. This bonds making between two atoms in the same line, C, and hydrogen. This is bonds forms between them. Region of sp2 hybridization is that carbon atoms formed three single sigma bonds. What single? C, and CH. I have three, CH, CC. CH single bond, and CH is another single bond. C one single bond. Now this atoms to achieve this To achieve this sigma bonds, each carbon atom needs 3 hybrid orbitals, which is YsP2. Okay, count with me. sp2, sp2, sp2. I have 3 hybrid orbitals. sp2 because I want 3 only, not 4. If I want 4, I will make sp3. Okay, I'm sorry. This is making as carbon. I illustrate that. I illustrate this excitation process. I illustrate the hybridization makes by carbon, but the human doesn't making anything. But we illustrate the hybridization process and carbon atom because it's easily distributes its energy and its orbital. Now, which is why sp2 hybridization occur. This is involved that mixing of one s orbital with 2p orbitals. I'm sorry, 2s, sp2. I have 1s plus 2b. Now, orbital resulting 3 hybrid sp2, s with 2b, x and y. Now, this hybridization sp2, I illustrate this in these shapes. I found here, firstly, 1s2, 2s2, 2b2. This is a carbon. Another carbon, 1s2, 2s2, 2b2. Okay, this is in ground state. Now, the electron here absorbs a little or a quantity of energy and will transfer in this space and this space of Bz. Now I have S1 to S1 to Bx1 to By1 to Bz1, and the other in this other carbon atom is the same. They are identical in this process, an excitation process. Now I have 3 bonds now will making. Okay, this is S mixes with By and Bx, By and Bx. Okay, Bz doesn't share with this hybridization or By. In the first term, we explains about the difference between Bx, By, and Bz. I remind you, Bx in the direction axis x, By in the direction axis y, Bz in the direction z in the third dimension. Now, maybe Bx will transfer By and By will be transferred and Bz. This is not stable shapes. Okay. Okay. S will mix it with Pp. This is forming sp2, 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 and the other carbon identical for this Bz. We have two parallel By or Bz's now. This is side by side. I will illustrate in the next slides. In this case, ethylene, 3 sigma bonds. Each carbon atoms form 3 sigma bonds. 2 with hydrogen, and the other with carbon. Okay, this is here. Carbon with hydrogen, carbon with hydrogen, carbon with carbon, and the other carbon, carbon with hydrogen, carbon with hydrogen, and carbon with carbon. Okay, this is single bond, and single bond, and this bi bond. I will explain the bi bonds forming in this structural formula. 3 sigma bonds, each carbon atoms form 3 sigma bonds, 2 with hydrogen atoms and 1 with the other carbon atom. The 2b orbitals of on the 2 carbon atoms overlaps to form another type of bonds between them known as pi bond. Okay, in these structures we find here this is overlapping forming in this structure. This is head to head. This is head to head overlapping, collinear overlapping in this linear, in the one line. Okay, this is collinear overlapping between 2 I'm sorry, sp2 and sp2. Okay, this is sigma bond. Okay, sp2 and s, this is sigma bond. sp2 and s, sigma bonds. This is 2bz or 2by. It's no difference. And we have the same here in this carbon atom, the central atom here. It is forming sigma bonds with the carbon atom. Now here is sp2s, sp2s, and have 2bz. They are parallel, will overlapping. This is side by side, but this orbitals will overlap with 2bz. This is pure orbital. Pure orbital overlapping with pure orbital forming pi bond side by side. Which is the stronger? Sigma bond is stronger than pi bond. Sigma bond is stronger than pi bonds because this is side by side overlapping, but sigma bonds is collinear overlapping, so it is more action or more attractive or more stronger than the other. We have another explanation for these shapes: sp2s, 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 sp2s. We have 2bz, 2bz. They are parallel, forming pi bonds. This is the hybridization of carbon atom in ethylene molecule C2H4, where each carbon atoms undergo asp2. Hybridization, the molecule forms, and it becomes clear that after the excitation process. Firstly, we will explain about this carbon atom. Firstly, make excitation process, no overlapping, no hybridization before excitation process. Why? Because I want single electrons. The single electrons means bond electrons, bond pair. This is hybridization, this carbon atom in the ethylene molecule C2H4, where each carbon atoms undergoes Cp2. Hybridization, this molecule forms, and it's become clear that after the excitation process in the carbon atoms, hybridization occurs between 2p sublevels orbitals and 2s orbital. This is results in the three hybrids. This is the forming of these orbitals. Hybridization sp2 in these forms, each call sp2 to avoid repulsion. This is very important. Carbon suffering from this repulsion force. Any atoms search the way. Any atom search a way to reduce the repulsion force between the electrons. What is the way here? The way here is the hybridization process to ensure the repulsion force is in decrease from the other. Now, each called sp2 to avoid the repulsion force between the electrons as much as possible with space forming angles. Watch angle here. This angle here is 120. It is the evident. Even that's one is to be z orbitals doesn't participate in the hybridization process. And this hybridization process perpendicular. You form it is perpendicular in this axis. Perpendicular in this axis. Okay, they are parallel. Doesn't precipitate in hybridization process and perpendicular to the plane, passing through 3 sp2 orbital of this. After the hybridization process, carbon atoms, two types of orbital overlapping. Okay, so we have we have that. Now I have sigma bonds. Sigma bonds collinear overlapping. I told before what is the difference between sigma bonds and pi bonds. Now I repeat it again to ensure the idea about sigma bonds and pi bonds. The sigma bonds head to head. Sigma bond is head to head in this process. We find here this is process forming this. This is a sigma bond in this here in this location. Head to head overlapping of atomic orbitals occur when the overlapping orbitals are aligned along the same. I illustrated before the sigma bonds forming in this carbon atoms between two carbon atoms overlapping head to head, collinear overlapping between two atoms, head to head overlapping of atomic orbitals occur when the overlapping orbitals are aligned along the same line I called collinear overlapping. Collinear overlapping. This is collinear overlapping of this molecule illustrate the types of sigma bonds. The sigma bonds, an example of this overlapping sp2 hybrid orbital in a carbon atom, one s orbital of a hydrogen atom, as well as the head-to-head overlapping of sp2 orbital of one carbon atom with the sp2 orbital of another carbon atom and the ethylene molecule. Now I read before, I stated it before now, but I read to remind you for the hybridization process and the type of sigma bonds making forms to understand this good. Pi bond. I have two parallel pure orbital. I have two parallel pure orbital or pure atomic orbital. BZ, BZ or BY, BY, because they are perpendicular in the plane. This is side by side. This is overlapping between two orbitals. This is overlapping between two orbitals. Side by side overlapping atomic orbital occur when the overlapping of this section make pi bond. Side by side overlapping of atoms orbital occur when the overlapping orbitals are parallel. They are parallel. Okay, this is a central atom and the other is a central atom. Well, this is overlapping is side by side. Okay, collateral overlapping or side by side overlapping. An example of this pi bond, the side by side overlapping is 2BZ with 2BZ. 2BZ in carbon atom, the central orbital carbon atom, and the other central carbon atoms, they are close to each other, and this overlapping occur in this position. 2BZ orbital with 2BZ orbital of another carbon atoms, as in the ethylene molecules, in the acetylene molecules, and the other example. This is two carbon atoms are connected, one sigma bonds and two pi bonds. This is an C2H2 acetylene molecule. I illustrate before the ethylene molecule. Ethylene molecule. Now have many examples to explain that this is bonding here. We find this is approaches here. They are parallel. This is pi bond, parallel, pi bond, but sigma bonds in this section we find here, and we understand that from this structural form. We have another example to illustrate SCP hybridization. SCP hybridization difference from SCP2 and SCP3. The conditions for the forming hybridization depends on the number of sigma bonds I need. Sigma bonds I need. Or the number of electrons to form bonds or lone pairs, such as NH3. I need 3 bonds, but making sp3. Someone asked me why ammonia gas NH3 and it form NH3 three bonds, and the same things C2H4 form three bonds, sigma bonds, and I form Sp2. The difference between C2H4 and NH3, I have four positions. Three positions called three bond pairs and have one lone pair. I want four positions. This four position makes Sp3 hybridization. In Sp2, I want three position sigma bonds, but the pi bonds formed by the overlapping side by side. But in SB, in this section found here, I have carbon atom and carbon atom sigma bonds, and here the sigma bonds. I have two sigma bonds of each carbon atom. Okay, I will clear that. It is clear form. This clear form here, and I will explain the positions of hydrogen and hydrogen and carbon for this overlapping. From combining each diagram, that's after the excitation process I stated before, and carbon must be excited before, and hybridization step after the excitation process. Now it is clear from the combining diagram that's after the excitation process in the carbon atoms, hybridization occurs between 2p orbital from the 2p sublevel orbitals and 2s orbital. This hybridization results to SCP. This is SCP and this is SCP orbital. Now the hybridization forms here SCP only. I have two hybrid orbital to avoid the repulsion force between the hybridization. From the hybrid orbital, they spread out as much as possible, forming the angle is linear. So it is linear equal to 180. SCP hybridization in this sphere, I have sigma, sigma, sigma. Carbon forms two sigma bonds and two pi bonds. It is noted that two orbital in each carbon atoms 2pz and 2py don't participate in the hybridization process. Then this overlapping between the atomic orbital of each atom occurs to form the following bonds. I have two pi bonds and one single bond or one sigma bonds. This is forms here. This is SCB, 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 SCB. Okay, SCBS sigma bond, SCB, SCB sigma bond, SCB, SCB, SCBS. I'm sorry, SCBS. This is a sigma bond. Now we have this 2BZ, 2BZ, 2BZ and 2BZ parallel. They are parallel, forming pi bond, and these 2BYs, 2BI is they are parallel 2 pi bonds. Sigma bonds, this results from the head-to-head overlap between SCP orbital of one carbon atom with the SCP orbitals of the other carbon atoms, as well as from the overlapping of SCP orbitals of the carbon atom with the s orbital of the hydrogen atoms. These hydrogen atoms, two hydrogen atoms making the head-to-head overlapping. Results from the side-by-side overlapping between parallel to BZ orbitals and parallel to BY orbitals of the two carbon atoms. Now I finished my session, and next, inshallah, we'll start another type, but we need to stop a little to review the sessions before to collect this session and many questions. You must, before anything, review the 4 sessions before, and next session will review by using the assessments from the Ministry of Education, and discussing some things. And thank you for your meeting and good listening, and assalamu alaikum wa rahmatullahi wa barakatuh.